Another trend in the past year has been an emergence of standards that support a standards-based engineering approach. I'll go over different types of standards that are representative, although there are other standards beyond these as well. For vehicle safety, federal motor vehicle safety standards have been around for a long time, and also NCAP, which is a test program. They cover basic vehicle functions. They apply to normal vehicles that have no automation at all. They will have to change a bit, that if somebody wants to build a vehicle without a steering wheel, there may need to be some changes in either interpretation or implementation of FMVSS, but in general, this is a fairly mature area. Beyond that, there'll need to be a cybersecurity standard, although that's not the emphasis of this talk. Beyond basic vehicle functionality, ISO 26262 provides functional safety coverage, especially for computer-based systems. This applies not only to current vehicles with electronics, but applies to the electronics inside automated vehicles. Within the context of the driving function, ISO 21448 and ISO TR 4804 specifically cover things such as issues with the environment, the fact that sensors aren't perfect, and dealing with edge cases as you create automation. Beyond driving safety, UL 4600 addresses system-level safety for the entire vehicle, including non-driving functions, and is designed to work in concert with the other standards shown here. Beyond providing a scope for consideration of system safety, UL 4600 also shows how to make a highly automated vehicle safety case to make sure that nothing was left out that's relevant to safety when applying the other standards.